Okay, we're looking at triangle similarity here. We've got two triangles which we're saying are similar. We need to make sure that our similarity statement is accurate, and by that, corresponding parts of the triangle, just like congruent triangles, have to be listed in the correct order. So if we could figure out which sides are corresponding to each other, for instance, 5 is the shortest side of this triangle, 10 is the shortest side of this triangle, so those are corresponding parts. 8 is the next smallest side, so it corresponds to 16, which is the next smallest on that triangle. And then we have 9, the longest side, it's corresponding to this side. So now we have to figure out which angles are corresponding to each other. Now we'll notice that, look at where the blue line and the red line meet. That would be this angle. So those two angles are congruent. The red and the light blue angle meet here. The red and the light blue angle meet here, so those two sides are congruent. And then we have the other angle, the smallest angle, being that one. So they're congruent. So now if we look at these, we have to see that corresponding parts are listed. Look at A, the D, and the C. Yes, those two angles are congruent. They're corresponding. The O and the A. The O is not congruent to the A, so they are not corresponding. That would not work. We could not make that similarity statement. Look at B. D and C, we already said that those two were. O and T, yes, O and T are congruent, and then G and A. So yeah, that would be one way to write a similarity statement for these two triangles. O and A are not congruent. Here's O and here's A. They are not congruent to each other, so that would not be a similarity statement. And then D and C are, and G and A are, and O and T are. So yes, so B and D would be ways we could write similarity statements. So now we're going to talk about how we can prove triangles similar. In our notes for this section, we're going to say that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So if we have two angles that are congruent, we can say that the triangles are similar. In this example of this drawing right here, we could make the statement, if angle A is congruent to angle F, and angle B is congruent to angle G, then, and our similarity statement would have to be triangle, we'll say the first one is ABC. It doesn't matter what the order of the first one is, our similar symbol, triangle, but now corresponding parts. A corresponds to F, so that has to go first. G corresponds to B, and then H corresponds to C. So that would be our similarity statement. So looking at the examples right here, determine whether the triangles are similar. Well, at first glance, we say, well, those two angles are not congruent, but maybe they're not corresponding. If we find out this missing angle, we will see that its measure is 75. That means that this angle is congruent to this angle, and it also means that this angle is congruent to this angle. We have two angles that are congruent, therefore, both of these triangles, they are similar to each other. So now our similarity statement will go JKL, and it's similar to triangle. Well, J corresponds to Q. It's the one angle that we didn't mention. So we'll say Q. K corresponds to P, and L corresponds to M, since they were congruent to each other. And that would be our similarity statement. The reason we could say that is because of angle-angle similarity. This right here. We have another picture here. Let me zoom in on this one. Notice vertical angles are congruent, right? Now, these red arrows here mean that those lines are parallel. If they're parallel, remember, if we have a transversal and RW is a transversal, then alternate interior angles are congruent, which makes these two angles congruent. Now we have two angles that are congruent. We can say that the triangles are similar. So triangle RSX is similar to triangle. What angle is congruent to R? W. So we're going to start with W. What angle is congruent to S? Well, S is. And then X would be congruent to T. That would be my statement, and the reason is because of angle-angle similarity. There are three ways to do it. Angle-angle is the first one. The second one we'll look at right here. If the corresponding side lengths of two triangles are proportional, notice that's not congruent, it's proportional, big difference, then the triangles are similar. So if all three side lengths are proportional, that means the ratios are equal to each other, then the triangles are similar. For instance, if we were to find that the ratio of JK, which corresponds to MQ, if we were to find that that ratio is equal to, I'm sorry, not JQ, that would be JP. JK, MP, if that ratio was equal to LK over QP, because those are corresponding sides, and they were that was equal to JL over MQ, then the two triangles would be similar. And my statement would be JKL, and again, I'm just randomly picking three letters in that first one. I don't know where I got three. I guess I said three, didn't I? JKL, and corresponding angle to J would be M, corresponding to K would be P, corresponding to L would be Q. And we would be able to make that statement because of angle, or I'm sorry, side, side, side similarity. All right, the third and last one that we're looking at today says that if the lengths of two sides of one triangle are proportional to the lengths of two corresponding sides of another triangle, and the included angle are congruent, then the triangles are similar. What that means is if we have SR, the ratio of SR over YX, if that's equal to the ratio of ST over YZ, and the angle that's made up by those two sides, which is angle S and angle Y, if they're congruent, then we have a similarity statement. And the similarity statement, again, we'll say RST, similar to, corresponding to R would be X, similar, corresponding to S would be Y, and corresponding to T would be Z. And we would make this statement because of side, angle, side similarity. All right, so let's look at some examples. Here we have, notice I have all three sides in both triangles. If I could prove that the ratios were the same for all three sides, then I could say that the triangles were similar. So let's do that. The shortest side is 5 on top, and on bottom it would be 12.5. Well, if I figure out what that ratio equals, it equals 0.4. And if I look at the next shortest side, that would be 15. I'm sorry, I would start with the top one since I did the other one. That would be 6, and then the bottom triangle would be 15. that is a decimal, is also 0.4. And if I did the longest side, small triangle on top, large triangle on bottom, that would equal 0.4. The ratios are all equal to each other, therefore triangle PQR is similar to triangle, what corresponds to P? Well, remember P is opposite the shortest side. So what side is angle is opposite the shortest side? S. Next would be Q, which would be T, and then R. And we can make that statement, explain our reasoning. Which of those three is it? Side, 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 angle, or angle, angle. We really didn't use angles in this one, so it has to be side, side, side. We compared all three ratios. And there you have it. Okay, on B, we're looking at it, and it doesn't necessarily look like two triangles at first, but you'll notice we have a smaller triangle within a larger triangle. So with this one, notice that we have an angle that they share. I don't have any other angles that are congruent, and I don't have all three sides, but I do have two sides. And if I have those two sides, I'm going to be able to use side angle side similarity. So I have an angle that's congruent. If I used the dark blue side and I looked at 8 and I put it over, I need this length right here. Well, that's 8 plus 4, which is 12. And that simplifies to 2/3. And if I do that with the other side, I'm looking at 10 over the whole length, which is 15. And that simplifies to 2/3 as well. Since those two sides are proportional, their ratios are the same, and the angle is congruent here, they are similar because of side angle side similarity. So we would say that triangle AFE is similar to triangle. Corresponding angles or corresponding parts would be A, corresponding to F would be B, corresponding to E would be C. And there you have it. And then you're going to have about 10 questions similar to this next problem. Here they're telling us that they're similar, so we're going to find missing lengths. So we have the large triangle, which we know all three sides for. Then we have the small triangle, which we're looking for X and Y. So if I know, look at this, I know that side is 3. Corresponding side on the large triangle would be this side, which is 5. So I'm going to set that equal to this side, X, over the corresponding side, which would be 3.5. Now I'm going to cross multiply and solve for X. 5X equals 10.5. Divide by 5, and X equals 2.1. X is BE, so segment BE equals 2.1. So we're going to do the same thing, and we're going to use the same ratio, 3 over 5, set it equal this time to Y over, Y corresponds to this segment, which we don't have a number for, but I do know that it's Y plus 3, and we can use that, Y plus 3. Cross multiply, we get 3Y equals, 5Y. 5Y equals 3 times Y plus 3. We'll distribute that. Subtract 3Y, and you get 2Y equals 9. Divide by 2, and Y equals 4.5. Now that's not my answer, we're looking for AD. AD, you'll remember, was this segment, which is Y plus 3. Well, we found Y to be 4.5, so 4.5 plus 3 is 7.5, and that's the length of AD. Okay, you'll see problems similar to this on your homework assignment and similar to the previous two we looked at. That's it.